If everyone's happy, I'll get started. So welcome to Easy Microservice Debugging on Kubernetes with the CNCF Telepresence tool. We're going to be looking at what I call local to remote hot reload today. Now, I always like to start my talks with a kind of high level key takeaways, TLDR, right? The inner development loop can be painful when you move to microservices and Kubernetes. Now, this is the kind of, very fast build, test, code, that kind of loop. And with microservices, there's just more things, more dependencies. And with Kubernetes, there's more layers, right? It's a bit turtles all the way down sometimes. You've got, a container running on Kubernetes, running on VMs, running on bare metal. Networking is a bit complicated sometimes, and just the container runtimes are, add more complexity, right? Telepresence, open source CNCF tool, proxies your local machine, got my laptop to my side here, into a remote Kubernetes cluster. So I can address the network namespace in the cluster as if I was in the cluster. The demo will make this clear. It is a super powerful feature. It's the reason I actually joined Master Labs when I saw it four or 5 years ago. I thought it was such a cool tool that I wanted to learn more and work with the company. Telepresence supports several workflows. I'm not sure if I've got time to go into them today, but I'll share various workflows in the slides and we can have a bit of a chat at the end around these things. I do generally find when I work on open source projects and we put them out there that the community is amazing and they use the tools in ways you never thought possible. So I've learned a bunch from the community on how they use Telepresence. I'm not a Telepresence engineer. I've worked with it for many years. The Master Labs crew have been working on it for quite some time now. Engineers are amazing. The community folks are amazing, but I've seen it used in all kinds of workflows, which I'll cover today. And lastly, it is a cloud native computing foundation tour. We just had KubeCon last week. I was there virtually. It was running in LA, but unfortunately in the UK, we couldn't get across. But it's a CNCF project. Telepresence was talked a lot about at KubeCon, fantastic community around it. And as with all open source projects, it relies on you getting involved, whether that's contributing docs, doing some Q&A, doing some code reviews, that kind of stuff. So one of my calls to action is to get involved with the project if you like it. This is me at Daniel Bryant UK on most of the interwebs. Love getting involved in Twitter, GitHub, LinkedIn, that kind of thing. As I mentioned before, the UK, I'm literally based outside of London, hence the UK on the end of the name there, but you can find me, love to interact with folks. Very quickly, background, started as an academic, from AI, moved into Java development, moved into ops, moved into solution architecture. I just love learning and I had fantastic opportunities at big companies and small companies, startups, to learn many things. So I've written a couple of books along the way with some awesome friends of mine, Continuous Delivery in Java, shameless plug behind as well. And I'm working on a new book at the moment called Mastering API Architecture with my buddies, Jim and Matthew as well, Matt, from work at Morgan Stanley. So yeah, get in touch. I love interacting with folks online. But enough about me, right? You're here for Telepresence. You're here for debugging microservices. So let's set the scene. Fantastic blog post by Mitch Denny. Unfortunately, it's a 404 now, the original post, but you can still find a link to it on the internet. And what I would say is, hopefully everyone can see my screen. I've just got a warning pop up there. Hopefully everyone sees the screen. What I would say is when I started my career working on Java monoliths, it was very much focused on the inner dev loop, test-driven development. You write a test, you do some code, and then you go in this inner loop very fast when you're coding. And then once you've sort of got so far in your feature, you then push it into what we call the outer loop, right? That's when you do tests against dependencies, maybe a database, other things like that. You do continuous integration, continuous delivery, all these kind of deeper tests than just in your little IDE, your little coding world. Definitely worth checking out this blog post. It's an interesting model. I'm sure many of you as engineers, many of you QA folks, architects will recognize. You move from that inner dev loop to the outer dev loop. Super fast on the inner as you're coding away. The outer tends to be a bit slower. The challenge when you move to Kubernetes is the inner and the outer loop can be somewhat similar, right? You're writing your code, you're building a container. That's the standard unit of deployment these days. You're pushing that container to a registry. You're deploying that to a cluster. You're running your tests. Oops, I forgot to add a system.out.println, right? Or I forgot to add a printf. Got to redo the thing. And this can be super slow. Now, obviously, you want to keep coding as local as possible for as long as possible. So big fan of mocks, big fan of stubs, doubles, all that kind of good stuff. But in my experience when I was a consultant working on microservices, sometimes even your inner loop needed to interact with dependencies. Mocks only get you so far. They have coded assumptions, right? Service virtualization only as good as the latest data capture you've got, that kind of thing. Sometimes to get that fast feedback, you actually want to have the dependencies around you when you're in a dev loop. Automation can help. Fantastic open source tools. Just going to shout out a bunch. Scaffold from Google automates the container build and push cycle in the background. I can be coding away, my container is building automatically, or my file is being synced up into the remote Kubernetes cluster. Similar deal with Garden, GitCube. I think Draft actually has been retired now, but I put it there for completeness. It was a Microsoft product for a while, open source. Octeto, always chatting to the Octeto folks, and the Tilt folks are awesome too. They're all in strong representation at KubeCon. You can check out presentations from last week as well. Do check out DevX Day. It was a co-located KubeCon event, and I had some fantastic conversations on this kind of topic out there. So quick search on the internet for DevX Days, great presentations. Sometimes, though, you really want that fast inner loop. No Docker build, right? No container build. And this, again, takes me back to my Java days where I'd have on one screen my IDE, or one part of my screen, my IDE. I'd be coding, I'd hit save, it would compile automatically. I'd get hot reload, and I could see the results of my web app that I was building on the side. So I had everything in my world on my IDE, right? In my running on my laptop, running on my computer. Super fast in a dev loop, hot reload. You know, Spring, a lot of the frameworks in the Java world had that baked in. Zero turnaround, awesome product that used to help out with hot reload. But I got that fast feedback that I craved as a developer. Make a change, see the results. Make a change, see the results. You also want to use your own tools sometimes, right? Again, you know, you're building this container, pushing up to a remote registry. Sure, you can open ports, you can do remote debugging. It can be painful though, right? Because, you know, remote debugging is painful at the best of times. The more layers you've got in the mix, Kubernetes, containers, VMs, I find the harder it generally is to open the right ports and to shut them when I'm done. So I'm not leaving a massive security hole in production, for example, or staging wherever I'm working. So it's tempting to try and run everything locally. This kind of works, you know, you spin up Docker, love a bit Minikube, right? Micro-K8s, K3s, take your pick. It works if you're a small company, small amount of microservices. It soon breaks down, I find, and particularly I'm a big fan of the Java ecosystem, right? But I'll poke fun at the JVM a little bit, the Java virtual machine. Like even though I've got a fairly, hefty laptop to my side here, 64 gigs, one of the latest Intel spec on Mac, I can only run a few services, a MySQL DB, a Kafka cluster, before the poor laptop's fan is just going all the time, right? So it's really tricky once you get to a certain scale to run everything on your local machine. This is where Telepresence comes into the fore. Open source CNCF tool, telepresence.io. I'll give you all the links later on. You can check it out. Telepresence is many things to many people. I've heard it called a fancy Kubernetes VPN for development. Someone last week actually said to me at KubeCon, "Oh, this is an application." Actually, I think I said to Peter, there's my ex-colleague now, Peter. I think he's actually at ATO as well. They said it was an application VPN. I've heard that phrase before. It's like a VPN into the cluster, VPN into the application. If you're familiar with kubectl, the command line Kubernetes, it's like kubectl port forward on steroids. Sure, kubectl port forward, you can do individual services, right? Individual pods, but Telepresence puts you right in the cluster. It's also a little bit like kubectl proxy, all the things. Kubectl proxy only really gets you to the API server. Telepresence gets you in the whole cluster. Fundamentally, it is a network bridge between your laptop and a remote Kubernetes cluster. Telepresence 1 was very much a swap deployment mechanism, put a proxy in place of what the service was running in there, and you proxy traffic from the remote server to your local machine and back again. Telepresence 2, that was released earlier in this year, does some slightly clever mechanics. It uses sidecar proxies. If folks are familiar with Envoy, it actually uses Envoy, but if you're not, don't worry, it's just a detail. But now Telepresence 2, which is just called Telepresence now, is a lot more flexible in the way you can use it as a dev and debug tool. Just to set things up, and hopefully I've got my animations here, I'm going to show you in a moment a live Kubernetes cluster running up in GKE, and I've installed Ambassador Edge Stack as an ingress, standard Kubernetes ingress, obviously by Ambassador Labs as well, but there is an open source variant called Emissary Ingress, CNCF project. I've got a very large Java service generating my web page that I'm going to see, but that very large Java service calls out to a data processing service, a fake kind of data processing service, and that data processing service calls out to a very large data store. Now, these are all made up things, right? The very large Java service is just a Spring Boot app, the very large data store, Spring Boot app, and I've got various flavors of the data processing service in Node, Python, Java, that kind of stuff. These are synthetic examples, but hopefully you can get a feel for what could be in the real world, right? You've got a couple of big services you can't run on your local machine, and you want to get a fast feedback loop on a service that is in the middle of a call chain. So some stuff's coming in from a user request. You want to work on that service, but you want to call into other services in the cluster. What you really want to do is move the data processing node service here onto your local laptop, but still have the network connections working. And that's what Telepresence gives you. Yeah, I've literally got the animation there, right? You want to move it onto your laptop. This is what Telepresence looks like now. When you spin it up, you get a traffic manager deployment installed in your cluster. That kind of gives us a hook, a proxy, a tunnel into the cluster. And you also get a sidecar running next to every pod, running in every pod, next to every container in your target service you're working with. And that'll become a bit clearer in the demo as well. But you can basically now route traffic from the remote cluster to my local machine. I can make calls in my local machine into the remote cluster and then return the results to the user. So I'll call the ingress, I'll call the main application entry point as I normally would in the, to the remote cluster, but traffic will be rerouted to my local machine. I can do some debugging, send it back in, and the user gets the results. Again, the demo should make this clearer. Just to show you how traffic flows, users make a request through the ingress into the very large Java service. It'll hit the Telepresence intercept when I fire that up. That'll get routed to my local machine. I can call out to the cluster, still send traffic back. The demo will make this hopefully a lot more clearer. Let's drop down to the terminal, right? Fingers crossed everything is up and running here. Hopefully you can all see that. Do shout in the chat if you can't. I am running on a Mac. This is a stand. I've got an aliased kubectl to K. So you'll see me typing K just to save my fingers and my keyboard. So when I've typed here already, K get service, everything, -A in the cluster, you can see I've got a basic Kubernetes cluster running up in GKE. I've got an ambassador, the edge stack ingress installed here. I've got my 3 services I talked about just a moment ago, very large Java service, very large data store, data processing service running in the default namespace. So if I just do K get service without any qualifier, you can actually see those 3 services are running in the default namespace with the Kubernetes mechanics behind the scene. That is my basic setup at the moment. I can, because I'm running Ambassador Edge Stack, I can do K get hosts. I will need to make sure it's in the namespace of Ambassador. And I can see I've set up a host here. If I copy paste that into, spin up a new Chrome window, paste that in. Now the application I'm rendering here, it's a bit meta, right? As in I've literally hit that target URL endpoint for my remote cluster. So I'm making a request into a remote GKE cluster. The page I'm rendering literally shows the architecture on the front page, right? You'll notice the font is in green here. This is the remote config running in green and the data processing service in green here. But I can literally hit that endpoint, right? And I see my web app. And you could do the same. You can hit up Frosty Cohen 2352. Please don't when I'm doing my demo in a moment, but you can, this is the legit like available URL endpoint. What I'd like to do, I know, for example, the very large data store, I know, for example, the data processing service has an endpoint like /color, and it shows me the green color. Now, I mentioned the green font, the green box. I would love, in my little fast feedback loop here, to be able to curl effectively, right? Just reach into the cluster and say, curl data processing service. It's in the default namespace, right? And we know it's running on port 3000. Got that in the metadata there, port 3000. And if I know, and I've even spelled it in US spelling for you here, right? If I know the /color, I would love to be able to curl that, right? Because then I could, spin up my ID, I could reach into the cluster, and I could actually be like I was in the cluster. Now, obviously, I can't do that because I've got the ingress exposed, the application, but the network namespace of my Kubernetes cluster is private. Yeah, I can't reach into it without doing a kubectl port forward or something. But Telepresence opens the door. If I now do Telepresence, let me just clear my screen for you, make it clearer. Telepresence Connect. It asks my password because we set up what's called a ton device and do some IP rules changes as well. So it does have to run as sudo at the moment as root. It'd be pretty hard not to do that actually, but don't worry, it's just asking for your password to set up the details there. Telepresence is connected in. I can now do telepresence list. I can see the services I can interact with from a telepresence mode. But the super cool thing already with just the Telepresence Connect is I can scroll up through my history. That was the curl I did just a moment ago, right? Curling my data processing service, default namespace, port 3000 /color, hit return, and I get a result back. Now everything in the cluster is available to me over that namespace, within the network namespace, and not just the default namespace. I can, providing I've got permissions at a network level to access services, providing I've got RBAC permissions to be able to get into the cluster too. Telepresence does not circumvent security. I'll cover that later on. But providing I can access it in the cluster, I can now curl it. If I'm running MySQL, I can fire up MySQL CLI here. I can connect into remote MySQL, connect into remote Kafka. It's like my laptop is in the cluster. It's super useful as a developer, right? But where it gets even more interesting, I'll do the intercept. Telepresence intercept. I'll do it on the data processing service. I know it's running on port 3000, right? So port 3000, and just that it'll whir away a little bit. What this is now doing is it's rerouting all TCP connections from the remote cluster to my local machine. So let me spin up. I'm a big fan of IntelliJ, JetBrains products, awesome. I've got here, if I move my zoom around, a local copy of my data processing service in my IDE. This is a local Java app. If I now spin it up, you'll see some debug coming down here, some login. Looks good, it's all started, happy days. I am now running this service locally. We've got the intercept going on remotely, routing to my local machine. I'm listening on the right port locally. I should be able to interact now with the remote cluster. One thing I'll point out is I mentioned earlier, by default, the data processing service responds back green environment, safe environment. I'm going to respond back now blue, right? I've set the default color in my locally running service to blue. So if I hit refresh on my main ingress URL, fingers crossed, we see some debug wearing away in the bottom here. I've now got a blue color coming back, right? So now imagine I'm making a request against my remote ingress. It's being rerouted to my local machine, the data processing service. I'm doing my stuff and then returning data back. This is your super fast feedback loop. Let me just move this web page to the right, left even, sorry, and then I'll move my IDE to the right. I can do this in real time as well. So I actually started the data processing service in debug mode. So standard debug in IntelliJ. If I set a breakpoint now, again, if I move zoom around on the color, and if I do a refresh again, boom, breakpoint hit, right? Normal functionality in my IDE. I can debug around, I can look at things. I can see, for example, the color is very small. Don't worry if you can't see it. The color is being set in my watches in my variable list. If I modify that variable, now I know I've got orange available to me as well. I set the variable, I return the results back to the cluster, and I see in real-time changes I'm making. You get that hot reload, right? I can make changes, do different interactions with the cluster, and I can see it as if I was a user calling into that cluster. This is fantastic for your sort of typical, single developer type use case, right? Where it gets really interesting though is where you want to effectively carve off a little bit of the cluster for you to work on and reroute traffic to, but everyone else will not see your changes. Because at the moment, if you, for example, hit up the Frosty Cohen web page here, the URL, you will hit my laptop. And in production, this would not be a good look, right? All traffic suddenly being rerouted to my laptop, and in debug mode, it would freeze as well, right? So that would be a double whammy, not a good look. We really want to be able to carve off an area of the cluster. So let me set that up for you now. If I think I can leave this one running over here. Actually, let me stop this. I'll stop it so we're not running locally. I'll bring back the terminal, and I'll leave this data processing service. So telepresence, leave. Telepresence service looks good. Fine, I hit refresh. We should see green. We're back to normal, right? Happy days. So what I'll need to do now is log in to our cloud product. If I just do telepresence, free like sign up, GitHub, GitLab, Google, and so forth. There is a commercial offering, but there's the actual login itself just is free. And the reason we do this is we the preview URL I'm about to show you, the way you can share your little part of the cluster, we want to provide audit capabilities there. We want to make sure that only folks that should be able to access that URL can. That's why we've got linked it up to our cloud product. So if I just log in, standard login to Ambassador Cloud using GitHub, that just takes a minute or two. I'll select my little fake organization at the bottom here, and we should see Telepresence come back happy. This is our cloud product here. If I just quickly search for data processing service, because we can see it. Oh, I'll need to do the intercept first. That's fine. No worries. So I've logged in successfully, looking good. I'll now just clear my screen for you. I'll scroll back up through my history and I'll reissue the intercept. Telepresence intercept, data processing service, port 3000. It's going to ask me some more questions this time because we're carving out this little private namespace, personal intercept. It's going to ask me about my ingress. And although I'm using Ambassador, you could be using Nginx, you could be using other ingresses. It should work the same. And if it doesn't, please do jump in the Slack and let me know. But we're just because we're setting up this preview URL, it's asking me a few more questions about how my ingress is configured. I'm listing port 443 because I'm using TLS, and I'm not using SNI, any fancy namespacing. I'm just using the Ambassador default namespace. But again, if you've got another ingress, this will be fine. The main requirement is you need to be able to propagate headers, HTTP headers, down your stack. So your ingress needs to propagate headers, as do your services in the call chain. And this will become a bit more clear, hopefully, in just a moment too. Looks good. That intercept has now worked. So I'll spin up my local Java service here, right? Fire that one up again. My local data processing service. That is good. And if you remember last time, I went to my main ingress URL, I hit refresh, and I saw the change to blue. Now I'm hitting refresh, I'm not seeing the change. This is because we're only selectively rerouting requests to my local machine. Everyone else is going to be hitting the main services. So I'm in my own little world here, right? We've made it super easy for you. You actually get a preview URL. All this preview URL does is it injects a header, X Telepresence intercept ID, UID, some other metadata. All this URL does is it injects that for you automatically. So if I now fire up that URL here, because we set the breakpoint gets hit in my IDE, I pass it through, and the default color of blue is rendered on my screen, right? And you can actually see a little banner. It might be a bit small, but I get bigger, maybe. No, I can't. But there's a banner on the bottom of my screen here. It says you are viewing a Telepresence preview. Now, by default, anyone from the same GitHub or GitLab organization as me, I could share this preview URL, and they could also view my work, right? So they'd have to log in to the Ambassador Cloud. We'd have to verify that they're from the same organization, but I frequently use Telepresence, like when I'm working with the UI team, the UX team. I'll share my code, they'll be giving me live feedback, and I'll be coding away and changing in real time. But we don't just want anyone accessing this preview URL, right? Because it could be hitting sensitive data, it could be, bunch of stuff like I don't want other folks to see while I'm coding locally, right? So by default, like you can share this, but the person using the URL would have to be from the same organization. I think if I actually pop into Ambassador Cloud now and refresh, I can even see if I just drill into this, the HUD pops up. I'm seeing I'm running one personal intercept. If I drill into the service details, you can actually see in the intercept the details of what I've created. There's the URL I'm using here, and you get an audit trail. If, for example, I did share this URL with you and you're from the same GitHub organization as me, I could see that you are watching this URL. So we get that audit capability too. Hopefully that all makes sense to folks. Let me just have a quick think. If I pop back, we get that fast feedback loop. Like I said, I've got my own little personal intercept here. Folks accessing the main URL, I can hit refresh all day. They're not going to hit my breakpoint because that's completely separate. I think that's pretty much all I wanted to show in the demo. You might notice, a few folks might have noticed earlier on, Telepresence does also allow you to access volumes in the remote Kubernetes cluster. So it uses SSH, I always get it wrong. It's SSH with some file systems involved. So you can actually mount volumes locally effectively. So if you've got secrets or other things you need when you're coding locally that would be available to you in the Kubernetes cluster, you might map a config map into a volume, a secret into a volume. You can access these locally on your machine too. So Telepresence routes traffic, but it also does volume mounts and a bunch of other stuff too as well. It's extending constantly with feature requests from the audience as well, or from the community. Let me now pop back. I think that's everything I wanted to show there. Pop back to the slides. I think we're looking pretty good for time for some questions as well. Let me just, pop back. So hopefully that's given you an overview of what Telepresence can give you. Jumps you into the cluster, you can call around and you can reroute traffic to your local machine, getting that fast feedback loop that sometimes is so hard in Kubernetes, so hard in like container-based technologies. Preview URLs I talked about. When we've got this sidecar running next to your container, running in the pod, that's where we're making selective decisions, right? So long as you pass the X Telepresence intercept ID down through your stack, the Telepresence proxy can make intelligent decisions of whether to route to your local machine or just pass it through into the regular cluster. So you've got to propagate headers. In general, it's not a big deal these days. If you've got like a newish project or greenfield project and you're using things like distributed tracing, typically with distributed tracing, you are passing headers along the microservice call chain anyway. Because to get distributed tracing, to get that correlation ID propagated down through the stack and back up, you need to make sure you're passing that with each request. So typically, a lot of the modern web frameworks, Spring Boot, all the Python frameworks, a lot of the Node frameworks have very easy ways to propagate headers down through your microservice call chain. So it's not generally an issue. When I'm working on more legacy money-making software, right, that's been around for a while, it can be a bit more tricky to propagate headers down through the stack then, but not impossible. I think I just wanted to run through here, like, yes, again, you're making a request against the ingress to the very large Java service. If you've not set the header, you go through to the main application. If you have set the header, you go through to my laptop in this case, right? So that's kind of where the routing decision gets made. Bit of a cheat sheet for you here. Telepresence Connect, Telepresence Intercept, login. I put some another cheat sheet on here. I'll share the slides with you and the ATO team, so you can grab these later on if you want to have a play around as well. I just wanted to, just in case the demo didn't work, I like to have it on slides as well. As a quick wrap up, now I think we'll take hopefully some questions. I wanted to show the good, the bad, and the don't try this at home with Telepresence, right? So the benefits with Telepresence is you can use any tool that runs on your laptop. I showed you an IDE, I showed you coding at the terminal. You can run a profiler, debugger, whatever you want, right? It connects to the cloud-based resources. Now, because of this, the same network namespace is available to you. So things like NS lookup works. You can curl into services as I showed you. You get that very fast loop, which hopefully you could get a taste of with me just like messing around with some of the debugging in IntelliJ. You get that very fast feedback loop of being able to intercept traffic and connect up to the same network namespace too. Requirements. This is where I was going just a moment ago, that you need a network, of course. If you're running everything locally in Minikube or K3S or whatever, you don't need a network connection unless you want to pull down dependencies from like NPM or Maven or something, right? With Telepresence, it is a network-based system, so you need to be connected to your remote cluster. What I would say is Telepresence 2 is a lot more fault tolerant. I can be on the train sometimes coding away, whereas Telepresence 1 wasn't very tolerant of disconnections. When I was getting on the train into London, it was a nightmare sometimes trying to use Telepresence 1. We have addressed that with Telepresence 2. You do need kubectl access to the cluster. We don't, I believe, actually use kubectl now to bootstrap the connection. We did used to until recently, but you do need access into the cluster. And again, Telepresence does no kind of security workarounds. If you do not have RBAC permissions into a cluster, Telepresence will not work. So people always ask me, oh, how can I stop Telepresence on my production cluster? I would say to those folks, it's a great question, very sensible question. Providing you have configured your developers to not access the production cluster via kubectl, which you should do, you are good to go. Telepresence respects the same APIs effectively. So RBAC is fully respected. We run on Mac, Linux, or Windows as well, and Windows, I should say. So just recently, we released a native binary for Windows. Fantastic community work. Thank you very much. And the Telepresence team at Ambassador Labs. We used to only support WSL2 with Windows, but we have actually a native binary now. So you should, regardless of what laptop, machine, OS you're using, you should be covered with a version of Telepresence. If it doesn't work for you, jump on the community boards, let us know, because networking is super hard on various, particularly on Windows, but on various different OSs. So let us know if it doesn't work for you, and you know, maybe even do a pull request and help us out, right? I have recently added this point because I get asked it a lot. Again, Telepresence does not circumvent security. So if you've got what's called network policies in Kubernetes that prevent a pod talking to another pod, Telepresence will respect that. There is a bit of nuance. You can check it out in the docs if you go to Telepresence docs. A bit of nuance with we mainly make requests from the traffic manager pod. So you need to set up your network policies accordingly if you're using network policies. And then when you start doing intercepts, it gets a bit, it actually looks like you're making a request from the pod you're intercepting. So it's a bit nuanced if you're getting this low level in the detail, but again, awesome docs. If it's not clear for you, let me know and we can hopefully, you know, make a fix to it. Same with service mesh. If you're using Istio, Console, Linkerd, a lot of them, well, all of them these days have policy configurations. You know, service A cannot talk to service B. Telepresence will respect that too, as far as I'm aware. If it doesn't, again, let me know. Layer 3 in the OSI stack, right? Layer 3, layer 4, network policies, Cilium, all the other CNI plugins, all that kind of stuff. Layer 7, service mesh stuff, we respect that too. Telepresence is not a hacking tool. I don't think. I'm sure it could be used to hack, right? But as in, it's not deliberately circumventing security. People often ask me, I could, you know, or say to me, I could build this tool in the weekend. It's just a proxy. Yeah, and this classic Hacker News comment, I love the Hacker News, right? But you get this all the time. Why is this thing so big? I could do that in a weekend. And I get this all the time. Why is Telepresence so big? I could do this in a weekend. Please don't. Yeah, the community's formed around it. It's open source. It's a CNCF project, vendor neutral project, right? It is really hard. Trust me, again, I'm not an engineer on the project at the moment, but fantastic team I work with at Ambassador Labs, fantastic community around it. It is really hard to get DNS right. It's really hard to proxy connections. Kubernetes, different resource types, deployments, replica sets, stateful sets, daemon sets. No two laptops are alike, particularly cross OSs, right? And no two clusters are alike. You might have different security policy config than I have. Nightmare. Let's all rally around one project, right? Rather than try and do our own things, is my advice. And lots of other things. It is a Cloud Native Computing Foundation project. Lots of great use cases out there. PTC, Cisco, you can read the names off the slide as well as me. There's lots of great interaction. I've been to many KubeCons and been surprised when people have been on the stage talking about Telepresence, how they're using it. Just last week, the Razorpay team, a unicorn in India doing payment services, we're talking about Telepresence. It's just awesome. It's humbling to see the impact of the tool. I'm going to pause on workflows. Let me just, if I just move I might have to drop down to the screen a moment, sorry. I've lost my mouse. I'm going to pause on workflows and go to the conclusion because I want to leave some time for some questions because that's often the most interesting part. So in conclusion of the talk part of the demo part, the inner dev loop can be painful with microservices and Kubernetes. Microservices, more things, more dependencies. Kubernetes, more infrastructure layers. Telepresence proxies your local dev machine into the cluster, get that fast feedback loop. It supports workflows. Again, I'll share the slides with you later. Like it's a bit more involved to explain some of these things, but you could hopefully you're picturing in your mind, right, how you could use it amongst your team as a workflow, you know, booster effectively for fast feedback and sharing preview URLs around the team, for example. And finally, please support CNCF project, open source. It's only going to get better if folks like yourself get involved. And that can be, again, everything from docs to raising problems to coding, the full gamut of things. You do not have to be the world's best coder. I'm certainly not, to get involved in this project. Whatever skills you bring, and everyone's got a skill, right? Bring it along, help us out. We'd really appreciate it. If you do want to contribute, again, documentation workflows, just, you know, shouting out how you're using it is super useful for folks. Letting us know if you're a user, basic, but it's really, really valuable, sort of proof for folks to rally around the tool, right? Triaging bugs is super useful, and lots of issues pop up on GitHub, and there's only a few of us in, you know, the company, and we're not a big company. We're trying to do the best we can, but community support is essential here. Join us on Slack, a8r.io/Slack. There is a dedicated Telepresence channel for you to get involved there. And I think that is my final slide. Call out to the websites if you do want to know more. Get Ambassador, telepresence.io. It's a quick start. We even give you a free remote cluster running K3S as well. So if you want to play around with, like, to get a feel for the workflows, you do not need your own remote cluster. We can spin you up one for like, it only lasts a couple hours and it's heavily sandboxed. So please, no Bitcoin mining, but do have a play around with it and get the feel for telepresence. Slack, I've already mentioned, we do office hours as well. Join us on there. I think finally you've got my email address there, and you can find me on, again, most of the internet at Daniel Bryant UK. That is a perfect point to pause. We've got 12 minutes, hopefully, for any questions. I'll definitely rely on your help, Michael, on this one as well. I'll look in the chat. Let me drop out on the screen as well and stop sharing. But I've seen a few questions already. I'll work through them, and then folks, if you want to put up your hands, we can come to you as well. It's great, Daniel. This is with Telepresence 1. Someone, Amrit, thanks for your question, pointing out couldn't get a connection. Yeah, Amrit, yeah. And we still see problems, occasionally with Telepresence 2 on this. And there is just so many layers in the infrastructure stacks these days, depending on whether you're running locally or was in on-prem tin, whether you're running GKE, or running Google Cloud, Azure, Amazon. There is a lot of variables in the mix. I would recommend, even though you have this problem with Telepresence 1, try with Telepresence 2. We use what's called a TUN device now, so networking is more flexible. It's more friendly with VPNs now. The community has rallied around with a bunch of issues that we've tried to fix as well, and the community's often helped there. So I'm a lot more confident these days of success using Telepresence, but just the sheer variables in the mix with networking and stuff, it doesn't work everywhere. So if you want to reach out to me on Slack or reach out to the team on Slack and let us know if you get stuck on a specific use case, we'll do our best to help you on that. Is unable to make connections to GKS, local authentication. Yeah, there's a bunch of challenges around. Again, Telepresence 2 offers more proxying options. You can proxy CIDR blocks now. You can proxy various suffixes on domains. Again, the docs are your friend here. I haven't played with it as much as I want to, but the Telepresence docs like Donnie and Luke and Thomas and the team have done amazing work in Ambassador Labs addressing some of these things. So you should be able to get more config in your Telepresence 2 options now as well. And then network issues, continuing the previous comment, there are limitations to communicate to things like S3. So again, providing the service you want to address is network addressable from your service, you should be good to go with Telepresence 2. And a little workaround you can use is to use what's called external names in Kubernetes as well. So if you've got, like, by default, I don't think you can reach out to, for example, like a RDS instance in Amazon, right? Because it's a cloud domain name. But you can map an external name onto that cloud specific DNS and use the external name in Kubernetes. But again, I think some of the new work on the CIDR block routing and the suffix routing may even allow you to route to things like S3 and RDS and other cloud equivalents as well. But let us know, because again, different clouds do different things at the back end. There is always an element of security, so a lot of things will fail closed by default, which is a good thing, right? So it does make our lives as developers harder, but it's good for a security perspective. Amrit, you got some great questions here. Like, I would recommend joining the Ambassador Labs Slack. Hop along to the Telepresence channel. Let us know how you get on, because just by raising these problems, you're doing a massive favor to the community, because we can then chip away at them. Some things may not be possible, but as in a bunch of stuff usually is once we get our head around it. Great questions. Did I see someone else pop into the chat there? Feel free to ask questions, folks, if you want. Let me try and look at you can raise your hand or add the notes. There's a Q&A function here as well. Do let me know if you've got any questions.
If there aren't any more questions, Daniel, feel free to use the remainder of the time for however you like. Plug anything else you would like.
Awesome. In that case, I can work through the workflows, right, that I skipped, because it does take a bit longer. But if folks are interested and you're still around, let me just fire up the workflows section here. Actually, sorry, I'll close my Zoom window. Can't do it once I'm presenting.
You have about 8 minutes remaining, so you know.
Cheers, Michael. Perfect. I'll whip through this pretty fast. So workflows, I see what I call the YOLO workflow, right? You only live once. You get fired by your boss for doing it. A simple workflow is if you not got product market fit, you're just a few developers experimenting, one production cluster, right? You can literally check out the code, work on the microservice, you can intercept services on demand, don't even have to log into the cloud. You can just, intercept all traffic, right, to your local machine. Once your coding's done, then you build a microservice, you would deploy it via pipeline. Telepresence isn't a deployment mechanism. It's a great fast feedback loop, but then you always commit your code and push it down the pipeline as you would with any other kind of code. Telepresence is not a permanent network connection, so to speak. Testing in production can be scary, but we actually have customers, community members that do use Telepresence in production, right? And they're really happy and they've got all the right safeguards and things. I think a lot of folks are chatting in the community when they hear about testing in production to give like a more enterprise kind of customer, right? You think this, right? You just the elbow on fire at that moment. Like, what? Testing in production? No way. And I totally get it. That's totally fine. You can use a workflow, like a typical workflow for a small, medium enterprise, small, medium business. You have a shared dev cluster, so a single source of truth microservices. You check out one of the microservices. You have to coordinate with other devs typically if you're doing intercepts in this context. But if you're mutating state, for example, Telepresence can be quite clever about selectively redirecting traffic. If you're reaching the customer and mutating shared state, Kafka, MySQL, Rabbit, MQ, whatever it is, right? You might break other people's stuff that they're working on the cluster too. So the coordination required. Watch for coupled service API evolution. If two of you are working, two groups are working on coupled services, like API coupled services, and one of them changes it, you might break the other person's code, right? So standard microservice advice, think about based contracts, think about blocking, slugging, testing, all that good stuff. I've already mentioned about mutating shared state. I've done it myself many times. I like to get that one out early. And again, you just coding locally, personal intercepts, sharing with your team, fast feedback. Don't forget to use that pipeline to deploy. Telepresence is not sure about getting your stuff in your project. I think I'm going to shout out Cesar here. Yes, so fantastic talk with DevOps UK a couple of years ago now. And he talked about his use case of Telepresence. So if you pop onto YouTube, you can find a bunch of Telepresence use cases that Cesar in London is fantastic. I talked with DevOps on his use case. More advanced workflow, Angular developers are fantastic for a couple of years now ago. Qton about Telepresence, they had one cluster, multiple namespaces, a namespace for each developer. They were like isolated the namespaces, but they were doing some really clever use cases around using Bazel for building containers and hooking the container build locally up to the remote cluster with Telepresence. I'm not going to do it justice. Check it out on YouTube. It's a great talk. These for power users. Remember that the team were asking fantastic questions, sharing really interesting ideas. It's Christian really a fantastic talk. Great chat in the booth as well. Angular developers team are pretty advanced on the Kubernetes use case. So do chat to them if you want to know they're on the community and so forth. Do chat to them if you want to know more advanced use cases for weaving Telepresence into your code dev lifecycle. I think we have all the links there. I'll share the slides again with everyone, with the ATO team later on as well. And actually bring you back my wrap-up slide, I think. Maybe if I leave the the thank you slide there, pop back into Zoom, see if there's any more questions. We've got 3 minutes. If anyone's got any more questions, feel free to add into the Q&A or the chat. Happy to take any questions. But let us know how you get on. Hopefully this is useful to you. We love hearing, if it's not as well, but jump in the chat either via ATO or via the Ambassador Lab Slack. Let us know, have a play around, let us know any rough edges. I really appreciate the community kind of driving how the tool evolves here.